Last step in this activity is to use a triply nested for loop. And I've copied this example here into my MATLAB editor. And the process for figuring out what this is going to do is the same as previously. First I say that this for in this end is asked to repeat everything that's highlighted 3 times with values I equal 1, 2, and 3. So I'll do that. Got to repeat this part that doesn't fit in the for loop. Set I is equal to 1. Set I is equal to 2. I is equal to 3. And then I'll just copy this. And now I need to look at this for loop, which is just a standard nested for loop. And I got to use my technique that I've used previously in the same way, just on this part of the program. So I do that. This says set j is equal to 1, j is equal to 2, j is equal to 3, and then do everything inside of that loop. This is once, twice, thrice. And again, the amount of space that you have at the beginning of the line doesn't matter. We use indentation just to make things easier for us to read. MATLAB doesn't really care. And let me get rid of this part now. So now I also need to do that same process for these things. But let me work on this part, this last for loop. And this just says set k equal to 1, and then set k equal to 2, and do everything inside of that loop. So I repeat this, and delete this, and then tidy up a little bit. And now I just do copy this, and I can replace all of this with that. Copy this, replace everything there. And this thing, this block of text, is exactly what used to exist below this I is equal to 1. So I can delete that, and I can delete this, and say, well, I know how to do this already. So I just take this fully expanded out version, copy it, paste it here, and paste it here. And so now I have a fully expanded triply nested for loop. And I can ask what the value of z is at the very end by running this. Again, white space doesn't matter, so I'll just leave that there. I'm going to copy this whole program into MATLAB. Where did MATLAB go? Here it is. Copy this into MATLAB, expand this window out, clear the console, paste, enter, and it tells me z is equal to 73. Now let me go back to my editor, and let me verify that I did this right. That long set of statements should be equivalent to this. Clear the console, paste, c is equal to 73. Now, a question that I'll start asking is, how many times was this statement evaluated? Well, I can just go up here and say 1, 2, 3, 4, 5, 6, and then I did it 7, 8, 9, 10, 11, 12 times, and then 13, 14, 15, 16, 17, a total of 18 times. So if you had typed this in manually, you would have had to type this line in 18 different times. Now there's an easy way to figure out that value 18. by just looking at this for loop. And after you've expanded out these for loops a few times, it'll be obvious how to figure that out. The general rule is that you take the number of values in here, there's a total of 3 values, number of values of here, which is 3, so 3 times 3 times the total number of values here, which is 2. So 3 times 3 is 9, 9 times 2 is 18, and so this will be evaluated 18 times. Keep in mind that it's the total number of values in here. So if I had changed this to 29, and this to 22, and this to 41, the answer is 4, because there's a total of 4 values in the square brackets. 4 times 4, which is 16, and then 16 times 3, which is 48. So this will be evaluated 48 times. And here's a trick to figure out how many times it was evaluated. Z is equal to Z plus 1. And so here, what's happening is every time it evaluates this statement, it changes its value by plus 1. So suppose I change this to 0. And so this is my program. Let's look at what the modified version looks like expanded out. I changed Z is equal to 0, and then I've just changed this to be Z is equal to Z plus 1, and then this to be Z is equal to Z plus 1. And so you can see here the value of Z will be equal to, Z is equal to now 0 plus 1. The value of Z will be equal to 1 plus 1. Value of Z will be equal to 2 plus 1. After I get rid of this, replace it with 1 plus 1. And so if I made those changes all the way down and then undid this, I would see the values of Z being displayed step by step. And so you can see a program written in this way essentially will count the number of times that this statement is being executed. So let's verify that. So the expectation here is that this statement, I said, would be evaluated 48 times. Therefore, at the very end, Z should be equal to 48. And it is. Sometimes we'll give these variable names something more descriptive. So Z is really the count of the number of times that statement was executed. So why don't I just call it count. 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 And the advantage of using a descriptive variable name like that is somebody could be reading your program and they say, this variable name is count, and then they would conclude, most likely it was counting something. And therefore it gives them a hint as to what your program is doing. There are other ways of doing that. You could add comments to say, this program counts the number of times the statement is executed. And now the reader will have 2 hints. One is a comment statement that MATLAB ignores, but that humans do not ignore. And then a variable with a name that is useful. And we call this index variable, which shows up after a 4. We typically use the letters I, J, and K. I think of I as being the first letter of index, and that's why it's useful. And then J is logically the next value after I, and you often need multiple index variable names, and so it makes sense to use that. And K is the next one following. You don't have to do that. You know, you could call this index, something like this if you wanted to. But again, the choices of lowercase I, J, and K are just conventional, and so most programmers use it, and therefore if you give your program to somebody else, he's going to have an easier time understanding what you did if you have names that are consistent with his expectations.